नमस्कार। विश्व मौसम दिवस के संदर्भ में आप सबको मेरे तरफ से और रीजनल मेट्रोलॉजिकल सेंटर गुवाहाटी की तरफ से आप सबके लिए शुभकामनाएं। आज मैं हमारा रीजनल मेट्रोलॉजिकल सेंटर का कामकाज क्या है, हमारा टारगेट्स क्या है, फ्यूचर प्लान्स क्या है, ये WMO के संदर्भ में मैं आपको जानकारी देना चाहता हूँ। Today we are celebrating World Meteorological Day because this WMO has formed or established on this particular day called 23rd March. ये आज का दिन में है. In today's day, the theme of today's day is early warning, means we have to warn about the weather very early, and then what action is taken by the meteorological office as well as the disaster management authorities to mitigate the weather, to cope up with the weather. The theme has been selected by the WMO Executive Council. The goal of this World Meteorological Day is to raise awareness about the various issues that the planet Earth faces. The day is significant as it reminds how Earth atmosphere influences the life of the human life and its vice versa. Then World Meteorological Organization wishes by 2030, now we are running 2022, by within 80 years, our goal is specifically to meet all vulnerable weather situations and withstand vulnerable weather, to recover very quickly from the very difficult weather situations, including the extreme weather events which is affecting the socio-economic implications. So, as all of you know that the weather is affecting almost all parts of the life. There is no such such division or such life which is not at all affecting with the weather. So that means life and weather are interrelated. So, for example, our weather is all of you know that weather is affecting the aviation for landing and takeoff, etc. We need to have the weather. If the weather is not there, the pilot will be it becomes very panic. He cannot take a decision to land at a particular runway. He cannot take a decision to take off also. Even the weather will influence its aircraft, the float rate, as well as everything it is going to affect, the Bernoulli's principle, etc. Then agriculture, all of you know that जहाँ जितना पानी बरसा है उतना agriculture पैदा हो जाएगा. Then some plants require less rain and some plants require more rain, that all of you know very well. Now this is affecting the agriculture. Then transport and tourism is getting affected. Power generation and distribution. Suppose you want to generate a power, you need a rain. From the rain you get, when the rain water flows down, then with the hydroelectric turbines, then the power is generated and power is distributed everywhere. Also, if there is a heat wave is there, then definitely load consumption will be more. Number of the air conditioners will be on, so that this load shedding has to be operated. So some places wherever heat is there you have to give more power. Wherever heat is not there, there you have to shut out or give the less power, etc. Then health. So health is also getting affected with the weather. So many vector-borne diseases, other diseases are related to the temperature, low temperature and high humidity, etc. Then the floods, the water accumulation. Definitely these are going to cause the health issues. The sports, for any sports event to be organized, people definitely wants that outdoor events, they will put a date where whenever there is no rains are there, it's a clear weather is there. Then sea travel, all of you know that if you want to travel in a sea from one place to other place, you badly require the weather information. Construction industries, you want to construct something, they will always look for the weather. Then defense people, even for doing the war also, they require a weather. For all manufacturing and distributing industries, suppose you want to manufacture a wool, suppose I predict somewhere the temperature will fall down like anything in the winter, so then more and more woolen clothes will be manufactured. Some places where the heat is more, then more AC, air conditioner equipments will be manufactured and then it is sold. So for giving the weather information, the observational network, what are the instruments which are observing the weather, whether it is a surface instrument, whether it is an upper air instrument, whether it is a radar, whether it is a satellite, or everything we require an observational network. Observational network will become a key instrument for knowing the weather situation at a particular place. For giving the early warning as per the WMO theme, early action for the mitigating the weather for the for the society and then safety, for their security, health, travel, and meeting all other requirements of the society. The observational network will play very key role in nowcasting, forecasting, and issuing timely warnings to the people for leading their comfortable life. So observational network acquire the weather information from the surface, from the upper air, from the satellite, from the radar, etc. And then this data is ingested into the weather models, the numerical weather models, for giving the future predictions. You can predict up to 5 days. You can give the seasonal forecast. You can give all types of the forecast and nowcast, etc. Then the climatology is another subject in the weather. There's a branch of the weather which is nothing but the long period average of last 30 years data at a particular place. The data could be at the surface data or upper air data also. From these two will help the weatherman to predict 3 months in advance, 6 months in advance, etc. These are the broadly divided observation network into 3 parts, that is satellite, including the both INSAT as well as the polar orbiting satellite, and then upper air network, that is a radio sonde, and then pilot balloon network. Radio sonde will give the, in addition to upper air, winds and other weather information like temperature, humidity, ozone, and other radiation, upper air radiation, etc. The pilot balloon will give only the winds. The surface network contains the automatic and then manual weather stations for continuously sampling the weather information. So as far as our Northeast India concerned, Regional Meteorological Center Guwahati, so these are all our surface meteorological network available within the RMC Guwahati, and the screen will tell you very clearly. Next. And these are the automatic weather stations. There are 2 types of surface weather network. One is a manual network that is continuously taken every 3 hours. Observation is taken at 0 GMT, 3 GMT, 6 GMT, and every 3 hours it is all over the globe at the same time. The observation is taken, and these observations are manual observations. They will take part in the calibration of the automatic systems, and then they used to, this manual data is required for the comparison of the comparison with the automatic, and then correction and other servicing. We are using the manual data. In addition to that one, we have many automatic weather stations in the Northeast India. As you can see, right now we are having the 82 automatic weather stations, normal automatic weather stations. Then in addition to there are 3 types of automatic weather stations. One will give the winds, temperature, pressure, rain at a particular place, and these 146 are there in the Northeast India, which will give only the rain information and temperature information. And as of now, we are having the 18 automatic weather stations, which gives, in addition to the automatic weather, it also gives some agricultural parameters like soil moisture and soil temperature at 4 depths, that is 10 centimeter, 30 centimeter, 70 centimeter, and 100 centimeter, which are very much useful for the farmer for their planning. And then it also gives the soil moisture information. From the soil moisture and temperature, the farmer will come to know what are the seeds he has to plant so as to get the better yield. And this also contains the radiation instruments. So you know that photosynthesis is one of the main thing. So all plant yield and growth depends upon the more and more photosynthesis. So that radiation also will tell the information on the yield of the plant. Now, as I already told you that there are some manual stations. Some of the manual stations are operated by the India Meteorological Department. Some are operated by the state government and part-time observatories. Some are manual observatories are operated by some other agencies. So India Meteorological Department is collecting all the manual information, collecting at one place, and we are continuously transmitting to our website and other places in order to as I said, that for the calibration purposes, and then for taking them as a standard for giving their weather network, etc. And in addition to all these manual observatories, we are having some seismological observatories also in Northeast India. One is at Tura, Imphal, Shillong, Agartala, and Lekapani is in Assam. So here you can see some of the manual instruments. that you can see the cup counter anemometer. This is the wind vane, mechanical wind vane, which is going to give information on the actual wind direction. This is the Stephenson screen in which your dry bulb thermometer, wet bulb thermometer is placed. And these are the autographic instruments which will record continuously the weather information on a chart for complete 24 hours. Every 24 hours the chart is getting changed. And this is hygrograph instrument. This is open pan evaporimeter manual instrument, which will tell you what is the evaporation happening, which is going to help the farmer about what kind of agricultural plant he is going to put there in his field. These are the automatic rain instrument. These are the thermograph instrument, barograph instrument. This is band speed anemograph instrument, which will give continuously the wind direction, wind speed. It is recording instrument. And these are the my earlier slide is the surface instruments. Now it is upper air instruments network. You can see Doppler weather radar. This is the dome of the Doppler weather radar, which will protect the radar antenna from the high winds and then heavy rains, etc. This is a microwave radiometer, which will give the continuously the upper air temperature up to 10 kilometers height. This is the visibility and present weather sensor. Of course, it is a surface instrument which will measure the visibility at a particular place. This is a wind lidar, which is going to give you the height of the upper air winds up to 10 kilometer height. Okay, this will give even when there is no rain, no clouds are there. Then also this wind lidar is going to give Then GPS radio sound is upper air instrument, so that this particular instrument is having all the sensors for the temperature and then as well as the humidity, ozone, and the upper air radiation instruments are also attached to this one. This simple radio sonde, and it is attached to the balloon, and it is also having the one GPS, which is going to measure the latitude, longitude, altitude of the places wherever the balloon is taking this system. From all these things, finally we are going to get the temperature, wind speed, wind direction, pressure, etc. at various levels in the atmosphere at a particular place, which is very much useful for the forecasting and nowcasting. And this is a laser ceilometer, which is going to give you the upper air clouds, that is height of the base of low cloud, medium cloud, and the high cloud, and also thickness of the each and every cloud, which is also very much important, crucially important particularly for the pilot for the landing and takeoff. And this is a rain sensor. This is our visibility sensor. So these are the upper air observatories of GPS radio sound in Northeast India. We are having at 7 stations. We are having Assam. All 7 states are having the is equipped with the upper air instruments. Then we have the PBO stations for taking the pilot balloon observation. There are in Guwahati, Mohan, in Manipur, Imphal, Tripura, Agartala. Then we have the 3 Doppler weather radar stations. Now we have one in Dibrugarh, one in the Cherrapunji, one in Agartala. So in future we want to expand the observational network. We are installing about 40 number of automatic weather stations in Arunachal, and remaining 60 number of the stations in automatic weather stations in other part of the other states of the Northeast India. Then 8 X-band Doppler weather radar is going to come in the Northeast India for continuously monitoring of the clouds and then upper air winds, etc. It is having it can take our observations up to 150 kilometers range, from which we can derive many valuable parameters which is required for the weather. All data processing server for reception of all automatic weather station data, rain stations and airport stations, and other data of Northeast India. Then what are the products we are generated from the observational network? If you take a GPS radio sonde, we get wind profile up to 35 kilometers height, then temperature humidity up to 35 kilometers height. Then it is also going to give you the thermodynamic indices for the better forecast for the Northeast India. Then it is also input, this data will be inputted into the numerical weather prediction models. Then Doppler weather radar, what products it is going to give? It is going to, from that Doppler weather radar, you are going to know what is a cloud structure, the thunderstorm cloud detection, and you can estimate the rainfall intensity, and you can also estimate the rain, how much rain is going to fall at a particular place, and you can use it as a nowcast, and you also get continuously the vertical wind profile, and the products from the INSAT. There is one INSAT is that satellite. There are two kinds of satellites are there. One is a geostationary satellite, which is that is INSAT, which is at 36 kilometers above the Earth, as all of you know that. So what are the products we are going to get? The visible products which are using the 650 nanometers from the actually how the satellite will do. The sunlight will fall on the Earth, and then Earth is going to reflect the light. Earth is going to reflect the light. This albedo light is reaching the satellite. From the albedo, from that one, the 650 nanometer is going to taken by the satellite. From that one, you are going to get the cloud, and what are the type of the clouds present, what are the raindrops, amount of the rainfall going to happen at a particular place, if there is any ice crystals in the clouds, that also will come to know. And this satellite is nowadays capable of giving in the winter where is the fog, and then what is the intensity of the fog at a particular place, that also it is going to give visible band. Then infrared band, we are using the 1080 nanometers. What is infrared? This one, the Earth is going to absorb all the radiations, then it starts emitting the radiations. It will start emitting radiations whether it is a daytime or nighttime or any time. So this infrared ray coming from the emitted by the Earth surface as a part of the black body radiation is useful for 24 hours, whether in daytime or nighttime. So what are the products we can get from the this infrared band? We will get the height of the different types of the clouds and its brightness temperature, and surface and cloud temperatures. Surface temperature, what is the cloud temperature, then intensity of the storm, rainfall estimation, and it is available for 24 hours as I already told you, because day and night you can get it. And tracking the cloud, you can track how the clouds are moving. From that you can also estimate what are the upper air winds. In case of there is a problem in the upper air network and radar etc., still satellite will give some clue about the upper air winds. Then it also gives the water vapor of which is 680 nanometers, the moisture in the middle and upper air troposphere, and rain nowcast and forecast, the middle and upper air winds and jet streams. It's also going to give the information on the jet streams also. Then what are our future plans of the Northeast India Observation Network? So we want to introduce the artificial intelligence in the automatic weather stations for making smarter observation network. Expansion of we want to expand the smarter artificial intelligence comprised AWS and ARG, and we want automatic rain gauge every 2 kilometers, so that any rainfall is happen which will it will not left undetected. And all cities of Northeast India, we want to put the rain information. Every city, at least in one city, we want to have at least rain stations of 25 to 30 to 40 rain network. We want to have very dense network. Then improvement in the weather, aviation weather instruments. Then more and more unmanned meteorological instruments for aircraft operations, and also we are going to introduce the aviation weather observing system for automatic landing of helicopter and then aircrafts. Then there is no, I want to tell you here that there is no air traffic control is required. Nobody is required. It is unmanned airport for landing, used for the landing of the aircraft. The system itself will tell the pilot and guide the pilot how to land on how he has to come, approach the runway and then land. And expansion of Doppler weather network to cover all districts of Northeast India, and then wind lidar for continuous monitoring of the upper data at the airports, including the wind shear is also most important nowadays. Wind shear is increasing due to the climate change, and warning to the aviation and forecasting community. Microwave radiometers we are going to install at many places for monitoring upper air temperature, humidity, and profile, useful for accurate weather forecasting for the fog and thunderstorms and other services in the Northeast India. And introduction of the digidometer for calibration of the radar and rainfall intensity measurement. So whatever the future forecasting services we wanted to give to the Northeast India, improved observational network will enhance the efficiency of the predictions. In addition to the artificial intelligence is applied for the numerical weather predictions, we are going to introduce AI into the NWP models for the better resolution and accuracy. Following are the target within the next 5 years. At least we want to give the prediction for 3 kilometer accurately for 5 days in advance. Improvement in the seasonal forecasting models to give district-wise monthly forecast for 4 months in advance. Improvement in the forecasting 28 days advance forecast, district wise and daily updated. Improving the accuracy in 72 hours advanced thunderstorm prediction, 3 km by 3 km resolution. Then fully automated block level forecasting system with better resolution 5 days in advance. Then regional level model will run RMC level for better resolution. Thank you very much for